Inferring date format versus parsing a parser. Pandas internals question. I've been surprised to find a few times that explicitly passing a callable to date underscore parser within pandas.read_CSV results in much slower read time than simply using infer underscore datetime underscore format equals true. Why is this? Will timing differences between these two options be date format specific, or what other factors will influence their relative timing? In the below case, infer underscore datetime underscore format equals true takes 1/10 the time of parsing a date parser with the specified format. I would have naively assumed the latter would be faster because it's explicit. The docs do note. If true, pandas will attempt to infer the format of the datetime strings in the columns, and if it can be inferred, switch to a faster method of parsing them. In some cases this can increase the parsing speed by 5-10x. But there's not much detail given, and I was unable to work my way fully through the source. Setup. I'm interested in knowing a bit about what is going on internally, with infer to give it this advantage. My old understanding was that there was already some type of inference going on in the first place because dateutil.parser.parser is used if neither is parsed. Update: did some digging on this but haven't been able to answer the question. Read_CSV calls a helper function which in turn calls pd.core tools.datetimes.to_datetime. That function, accessible as just pd.to_datetime, has both an infer_datetime_ format and a format argument. However, in this case, the relative timings are very different and don't reflect the above.
You've identified the two important functions. Read_CSV prepares a function to parse the date columns using _make_date_converter, and this is always going make a call to _datetime, pandas primary string to date conversion tool. The answers by @WillAid and @BigBang both seem correct to me in that they identify the cause of the slowness as repeated calls of the lambda function. Since you ask for more details about pandas source code, I'll try and examine each read_test call in more detail below to find out where we end up into _datetime and ultimately why the timings are as you observed for your data. Read_test. This is very fast because, without any prompts about a possible date format, pandas is going to try and parse the list-like column of strings as though they're approximately in ISO 8601 format, which is a very common case. Plunging into to_datetime, we quickly reach this code branch. From here on, it's compiled Python code all the way. Array_to_datetime iterates through the column of strings to convert each one to datetime format. For each row, we hit _string_to_DTS at this line, then we go to another short snippet of inline code, _string_to_DTS, which means parse_ISO_8601_datetime is called to do the actual parsing of the string to a datetime object. This function is more than capable of parsing dates in the YEMMDD format, and so there is just some housekeeping to finish the job. the C struct filled by pars underscore ISO underscore 8601 underscore datetime becomes a proper datetime object. Some bounds are checked. As you can see, dateutil.parser is not called at all. Read underscore test infer underscore datetime underscore format equals true. Let's see why this is almost as fast as read underscore test. Asking pandas to infer the datetime format, and passing no format argument, means we land here into underscore datetime. This calls underscore guess underscore datetime underscore format underscore for underscore array, which takes the first non-null value in the column and gives it to underscore guess underscore datetime underscore format. This tries to build a datetime format string to use for future parsing. My answer here has more detail above the formats it is able to recognize. Fortunately, the YEMMDD format is one that can be recognized by this function. Even more fortunately, this particular format has a fast path through the pandas code. You can see pandas sets infer underscore datetime underscore format back to false here. This allows the code to take the same path as above to the pars underscore ISO underscore 8601 underscore datetime function. Read underscore test date underscore parser equals lambda dt column strip time dt, %y%m%d. We've provided a function to parse the date with, so pandas executes this code block. However, this raises an exception internally. This exception is immediately caught, and pandas falls back to using try underscore parse underscore dates before calling to underscore datetime. Try underscore parse underscore dates means that instead of being called on an array, the lambda function is called repeatedly for each value of the array in this loop. Despite being compiled code, we pay the penalty of having function calls to Python code. This makes it very slow in comparison to the other approaches above. Back into underscore datetime, we now have an object array filled with datetime objects. Again we hit array underscore to underscore datetime, but this time pandas sees a date object and uses another function, pydate underscore to underscore dt64, to make it into a datetime 64 object. The cause of the slowdown is really due to the repeated calls to the lambda function. About your update in the mm/dd/ye format. The series S has date strings in the mm/dd/ye format. This is not an ISO 8601 format. pd. to underscore datetime s, infer underscore datetime underscore format equals false, tries to parse the string using parse underscore ISO underscore 8601 underscore datetime, but this fails with a value. Error. The error is handled here. Pandas is going to use parse underscore datetime underscore string instead. This means that dateutil.parser.parse is used to convert the string to datetime. This is why it is slow in this case, repeated use of a Python function in a loop. There's not much difference between pd. to underscore datetime s, format equals %m/%d/%y, and pd. to underscore datetime s, infer underscore datetime underscore format equals true, in terms of speed. The latter uses underscore guess underscore datetime underscore format underscore for underscore array again to infer the mm/dd/ye format. Both then hit array underscore strip time here. Array underscore strip time is a fast Python function for parsing an array of strings to datetime structs given a specific format.
Infer underscore datetime underscore format applies the format it deduces to all elements in a single pass, i.e. in a vectorized manner. By contrast, your lambda function gets called for each element, bringing with it a lot more call overhead and decreased performance. There is a request from 2012 for an explicit format keyword argument, which would theoretically give you the functionality you are looking for with the performance you desire. In lieu of that being implemented, your best bet is to go with Wes's suggested approach in the link and simply read the date in as a string, calling pt.to_datetime after the fact. Here are sample times from my machine to illustrate.
After paying closer attention to Panda's original pull request for infer format, I believe the passing of the parser directly is not compatible with Panda's ._convert_list-like method. Whereas Datetoodle's parser is not inherently parallelizable, Panda's convert list-like operations can action the parsing in parallel if they can infer the format. The post mentions the format is inferred from the first item, then all others get the same treatment. Being a mathematician, I would probably recommend taking 10 random entries and taking the majority parse format as the picked one. Update. As mentioned in the comments, and within the pull request, there are also comparisons between passing the format or the parser. Test gist. It might be worth a feature request to let the parser be a np.vectorize object or similar.